Students, now we can move to next very important topics. Electron gain enthalpy and electron affinity. First of all, you have to understand this difference. I will tell you what is electron affinity. In textbooks and in normal classrooms, both are used for same idea. I agree, they are saying they convey same idea, but there is slight difference. Okay, electron affinity means electron affinity EA. It is the ability of a gaseous element to attract an electron, towards it. Okay. What is electron gain enthalpy? It is the amount of energy released when a gaseous element take up an electron. Okay. Suppose you have an element X in gaseous state, take one electron, you are getting X minus and delta H electron gain enthalpy. Okay, plus this amount of energy released. This is an exothermic because heat is released. Normally it is exothermic, but there are some cases there is positive electron gain enthalpy. In this case it is negative. I added the positive means this plus this, that is negative quantity. Okay. If electron affinity is higher, electron gain enthalpy will be also higher. That is, more energy will be released. You imagine a gaseous atom, neutral atom. When you give an electron to that atom will give you energy back. Agree? If you give me an electron, I give you energy back. That energy is called electron gain enthalpy. Okay? Now, electron affinity means the tendency of an atom to attract the electron. Both are matching. Yes. Now, this is very important. Electron gain enthalpy is the opposite process of ionization energy. What is this meaning? Suppose you have yes. Suppose you have a question. The ionization energy of Na plus gas. Very careful. Ionization energy of Na plus, not sodium. Underline that word. Not sodium, but sodium ion gas is 5.1 electron volt. What is its electron gain enthalpy? Yes, ionization energy of Na plus is 5.1 electron volt. That is, this much energy is required to remove an electron from Na plus. Therefore, what shall be its electron gain enthalpy? It is an opposite. Therefore, just simple answer, it is minus 5.1 electron volt. That is, If Na plus wanted to release an electron, you have to give 5.1 electron, the 5.1 electron volt energy. If you give an electron to Na plus, if you give an electron to Na plus, it will give you 5.1 electron volt. That is represented by minus. Okay. Now, electron gain enthalpy depends upon different factors. Electron gain enthalpy depends upon different factors. Electron affinity or electron gain enthalpy depends upon different factors: size, nuclear charge, electronic configuration, etc. Okay. But suppose there is a question which is most electronegative. Arrange the following element in the increasing order of electronegativity or decreasing order of electronegativity. To answer, you should have a technique. I am going to that technique. Okay. We have following groups. Group 1, alkali. Group 2, alkaline earth. Now, group 13, boron family. Group 14, carbon family. Group 15, nitrogen family. Group 16, oxygen family. Group 17, halogen family. Group 18, noble gas. Okay. Normally the questions of electronegativity comes from these groups. There is no question from transition metals or intertransition metals. Okay. Now please understand, in group wise, halogens have most electronegative. Halogen groups, then oxygen groups, then carbon groups, then nitrogen groups, okay, then boron groups, then alkali metals, then alkaline earths, last noble gas. Halogens have most, then oxygen, then carbon, not nitrogen. You know why? Nitrogen group elements have half-filled configuration. That is 2p3, 3p3 like configuration. Half-filled is more stable. Therefore, when an element, suppose nitrogen, accepts one more electron, this half-filled stability is lost. Therefore, nitrogen group elements have little reluctance to take up electron. That is why their electron affinity, electron gain enthalpy less than carbon family. Now, boron. Now look at alkaline earth. You know why? Alkaline earth is 2s2 or 3s2 filled. They have no interest. Therefore, there it has filled towards ns2 configuration, s2 configuration. Therefore, they have also less tendency. Fine. Then alkali. Noble gas, very low electron gain enthalpy. You know, because they have filled configuration. Understand? Noble gas has positive electron gain enthalpy value, or its electron affinity is zero. They have no tendency to attract the electrons. No tendency. Therefore, its electron gain enthalpy is positive. What is the meaning? They will not receive the electron and give you energy. They will not receive the electron and will not give you the energy back. That is the reason. Okay. Now, I said you halogen are maximum. Among the halogen, this is the trend. Chlorine, fluorine, bromine, iodine. Among the halogen, most electronegative is chlorine. The reason has been discussed in P block. Then fluorine. Therefore, suppose there is a question, which is the most electronegative from periodic table? Blindly answer, chlorine. Second one, second rank fluorine. Third rank bromine. Fourth rank iodine. Then only comes our oxygen family. Oxygen family. In oxygen, most is sulfur, then selenium, then tellurium, then polonium. My dear students, among the oxygen family, the lowest is oxygen. Yes, among the oxygen family, the lowest is oxygen. Yes, it goes on. Now the carbon family, phosphorus, silicon, germanium, tin, then only carbon. The nitrogen family also like that. Phosphorus, arsenic, antimony, bismuth, then only nitrogen. In that nitrogen group, the least electronegative is nitrogen. In the carbon group, least electronegative is carbon. In the oxygen group, least electronegative is oxygen. In the halogen group, most is chlorine, not fluorine. Why fluorine? What is the reason for fluorine? Because of its smaller size. Why oxygen? Because of its smaller size. Fine. Now, last point. Please note down. There is an idea of first electron gain enthalpy and second electron gain enthalpy. I will tell you an example. Take the oxygen. An oxygen, take one electron, you get O minus. This is first electron gain enthalpy. Again it takes the electron and become O2 minus. This is second electron gain enthalpy. Likely we discussed in ionization energy. I think you remember it. It is negative, but it is positive. I summarize here. Every elements except noble gas, first electron gain enthalpy is negative. But every elements, irrespective, every elements, its second electron gain enthalpy is positive. I underline once again. Every element except noble gas, first electron gain enthalpy is negative, but every elements, irrespective of their nature, second electron gain enthalpy is positive. Okay, I hope this video is beneficial. Thank you.
Yes.